Okay, so on this warm-up here, it talks about yesterday's lesson, 2 big points from yesterday, z-score and empirical rule. So this first one right here is practicing z-score, which, if you remember, was your value, subtract your mean, divided by your standard deviation. Okay, that's all that does is just tell you how far away from the mean you are, how many standard deviations away from the mean you are. And it breaks things down and puts them on comparable levels. Your question on the test is going to look identical with this. Okay, so let's go through it. We got Bob's a 17-year-old male who's 68 inches tall. Then it gives the mean and the standard deviation for 17-year-old males. Then it gives the height of. So it's got Sue's height was 63 inches tall, and it's also giving you the mean and the standard deviation for 16-year-old females. So the 2 groups that we're comparing is 17-year-old males and 16-year-old females. Okay. Normally we couldn't compare those 2 groups together because obviously 17-year-old males are going to be taller than 16-year-old females. But relative to their age is what we're curious about. Relative to their age, who is taller? That's what z-scores for. So we got to figure out Bob's, and we got to figure out Sue's. Okay. How do I set up Bob's z-score? Who's got that set up for me? 68 minus 70. So right off the bat, we know that Bob is 2 inches below the mean. So what do I know the z-score is going to be? Negative, right? Now, that's all negative means with z-score. You're going to see that on your homework tonight. All that means is that you're below the mean. Okay. All right. Divided by what? 2.1. What's that end up being? 95. So negative 0.95. So that's 0.95 standard deviation below the mean. Kind of short for me. What about Sue? Sue's height is 63. Their mean is 64, so she's below the average as well. And divided by 1.2, what'd you get? It's negative again. 23. So technically, who's taller in comparison to their age group? Sue. Yay! Pretty doable question. All right, we can do that. Questions on that? That's all you have to do. All right, number 2. Number 2 says the SAT scores are normally distributed. It's giving you a mean and it's giving you a standard deviation. Using the empirical rule, I want to know the percentage or the proportion of people that score above 2120. In this case, we're only given 1 mean, 1 standard deviation. We're not comparing it to anybody else's, so we don't need z-score. We just use the percentages that we talked about yesterday with the empirical. Yeah, it's not bad. All right, this is practicing filling out a normal distribution curve with its percentages and its values. I asked the question exactly like this on the test. So if you can do this, you're good. So I gotta have the mean and then 1, 2, 3, 1, 2, 3. All right, what do I start with? I guess the mean, right? Goes right here directly in the middle. Now I'm talking about 2120. Really, all I have to do is go in the right direction. But in order to fill this out, remember all you do is just add your standard deviation 3 times to the right and subtract it 3 times to the left. So help me with my terrible math skills here. Thank you. 1960, 2120, 2280. Cut me some slack. I'm not good at on-the-spot simple math. It scares me. All right, especially if it's subtraction. So 1640, 1580, 1480. That's what I meant. And then 1320. Yeah, see, that's no problem. That's full credit. Also, you have to know how to fill out all the percentages too, right? All those percentages. Okay, but the score I'm worried about though is 2120. okay, which is how many standard deviations above the mean? 2. Okay, so if I'm saying, let's see, scored above, am I looking to the right of that value, to the left of that? To the right. So what I'm looking at is this percentage right here. What's that percentage? It's, yeah, so there's 2 different spaces here. There's the one that was 2.35 and 0.15.
Yeah.
So the total to the right of that value using the empirical rule is 2.5%. Yeah, makes sense. I mean, you're 2 standard deviations above the mean. You don't have many people who won't pass that. So, know those percentages, and you'll be fine. Questions on that? Question? Okay. All right, so so today's lesson is kind of going off of the normal distribution curve that we learned yesterday with the empirical rule. Whenever we learn those percentages, those were to help us find the percentages with exact standard deviations away from the mean, like exactly 1 to the left and right, 2 to the left and right. Okay, but sometimes I'm going to ask for the percentage when it's not an exact standard deviation away from the mean. So, like, what if I ask for the percentage of students that scored above an 1850? All right, that's great. I mean, I know this percentage, but I don't know this little section right here. And it's not like a proportion that I can just kind of like, oh, that looks like half, I'm going to divide for 34. No, you can't do that. Okay, there's actually like a table of values that you're supposed to use. These like huge table, I think it's called a Z table, that you go through and correspond all these values. It's ridiculous amount of work. It's not necessary because we have technology that will do it for us now. It's in the calculator. Okay, so that's today's lesson. It's called the NormalCDF. It finds the percentage of area under the curve. And whenever we're talking about percentages with like the empirical rule and stuff like that, we're talking about an area under the curve. That's why it gets smaller as we go on. That's why the percentage is smaller. The calculator is going to find that for us, or find the percentage. All right, so let's just kind of go through an example and show kind of what we're supposed to type in the calculator. And for the people watching the video, I'm just going to write down exactly what we're doing in the calculator. Okay. So I guess I'll write it right here. For normal CDF, it's the same exact menu as it was for the binomial CDF. So you're going to go to second, and you're going to press that vars button, second vars, and you're going to go to option number 2, I believe. It says normal CDF. Okay, that's what you're. That's the menu you got to go to. And whenever you do that, you're going to have to type in 4 values. You'll see a screen with 4 values, and we'll talk about what to type in there. Okay. All right. So it says the lifetime of the battery is normally distributed with a mean of 40, standard deviation of 1.2. And it says find the probability that a randomly selected battery is going to fall between 38 and 42 hours. Normally, those values would be exact standard deviations that use the empirical rule. It doesn't work out quite like that this time. I'm not going to fill out a curve every single time, but I will for this example, just so you can see what we're doing. So we have 40 as our mean, and we're going up and down by 1.2. So 41.2, 42.4, 43.6. And 38.8, okay, 37.6, and 36.4. All right, so it wants to know the probability that we are going to fall between 38, which is right here, and 42, which is about right here. It wants to know that percentage. It wants to know the area or the percentage between here, this shaded region. And the problem is I can't just add 34 and 34 because I don't know these pieces. So the calculator's going to have to do it for us. Okay? So it's 38 and 42. All right, so whenever you go to normal CDF, we're going to have to type in 4 numbers. I'm going to tell you what to type in, and then we'll go through and kind of do it together. Okay. So the screen's going to look like this. You're going to see a lower. You're going to see an upper. You're going to see a symbol that looks like a fancy-looking U, and then a fancy-looking circle. Those are the 4 numbers that we're going to be able to type in. The first number is the lower bound. It's how far left we're looking at on our graph. So in this case, what number is that? Yeah, 38. What's my upper bound? Yeah, 42. The next 2 symbols, the first one, that little U, it's called a mu. It's a Greek letter. It means mean. So what's our mean in this case? 40. And the little circle, can you guess what that is? Sigma. It's our standard deviation. So 1.2. Okay. So it's those 4 values you plug in, and it will give you that area under the curve. So let's do that together real fast. All right. So as a class, we're getting in this shaded region, it is 0.9044 or 90.44%. Okay. Makes sense to me. That's a huge chunk of my graph labeled. So that's a huge chunk of percent. What do you think the entire area underneath the curve adds up to? 100%. Yeah. Cool. All right, let's do another example. Yeah. So I got a 90% chance that whatever battery I pick is going to last either between 38 and 42 hours. Yeah. What about more than 42 hours? So I'm not going to draw the whole thing again, but it was 40 here, 41.2, and 42.4. So if I say more than 42 hours, 42 we said was right here. Okay. If I say more than 42, which direction am I shading? To the right of that value or to the left of that value? Yeah, to the right. Okay, I want to know that percentage right there. Okay, well, let's think about it. I need to do my lower, my upper, my mean, and my sigma. What do you think my lower is in this case? Yeah, 42, right? It's as far left as I go. What do you think my upper is going to be? Sure, a big number. Yeah, absolutely. So, because my upper bound is how far right I go. Well, technically this goes on forever. But once you get past like 4 or 5 standard deviations to the right, essentially the probability is 0. So as long as you pick a number greater than 4 standard deviations, you're completely fine. Just to be sure, I always type in like a bajillion. I just type in 1 with a bunch of zeros. It works. It's the same as typing in like 100 or 1,000 or something. It'll be close enough. The mean is still 40. Standard deviation is still 1.2. And do I need to go through the menu on the calculator again, or computer? Question there. What do we get? Wait, what? 0.0477 is what I think it is. Yeah. 0.0477. Let's look at it. Makes sense to me. We're getting 0.0477, which is essentially 4.77%. And that region that we shaded pretty much corresponds with that percent. That makes sense to me. All right, you're kind of far up there. You're not going to have many people past that. Or many bathrooms. Question on that? Yeah, OJ? Did you prefer it in however? Either one's completely fine. Either one's completely fine. Yeah, you're completely fine either one. Okay. All right, what about less than 42 hours? So again, 42 is like right here on my curve. If I say less than 42, I'm looking at the percentage below that, right? I want to know the percentage that we are right here. Should be a little bit bigger now, right? So let's think about our values there. Lower, upper, my mu, or my mean, and my sigma. What's my lower bound going to be this time? Yeah, negative a bajillion, right? we're going so far left, right? There's no bound to the left. Just put a really small number. As long as it's 4 standard deviations to the left, you're good. I'm always safe. I put negative a bajillion. What's my upper bound? 42. My mean is still 40, and my sigma is still 1.5. Anybody get it? Because that's 95.23%. What? Yeah. What's the other way I could have done this problem? The last problem we figured out this was 0.0477. So we literally could have just done 1 minus that percent, and we would have got the same answer. What I do? Oh, good. Oh, yeah. All right, whatever. Any questions on that? Does that make sense? The percent adds up to 100% left and right. How do you feel about normal CDF? Good? Yeah. All right, now, so that's if you're given a value, asked to find the percent. What if it's the other way around? What if I'm giving you the percent, but I'm asking for the corresponding value? Well, we need to work backwards, or we need to do the inverse of the normal CDF. So in our calculator, we have an operation that will do that for us. It is InvNorm, which stands for inverse of the normal CDF. Okay, it's the same direction as before, but you're just going to go one below it. So you're going to see a little option that says inverse norm. It returns the x value when given the percentage below the value. So if I'm giving you like if I want to know the value right here, then we got to type in the area below the mean, and it'll give me what x equals. Okay? It has to be below the area or below the value. Just look at an example. It says that we're talking about heights now of adult females. It's normally distributed, and we got a mean of 65.5 and a standard deviation of 3. My question is, what height do 85% of women fall below? All right, 85% of women fall below. Let's think about, first of all, where that might be on my curve. I'll start off right here. That's my mean, right? What percentage of the population falls below the mean? 50, right? So I know this right here is 50%. So if I wanted a value that's 85% below, is it going to be to the left of the mean or the right of the mean? The right of the mean, right? This is 50. I need to have a little bit more to make it 85%. Right? So I'm looking for the value on my curve here that gives me 0.85 below it. I know my mean is 65.5, so I know that value has to be a little bit bigger than that. Okay? It has to be bigger than that. If it's not, then we've done something wrong. So when you go to the screen, you're going to see that there's only 3 things you have to type in now. It's an area, it's the mean, and the sigma, or the standard deviation. So 3 things instead of 4. What do you think the area is that I'm going to type in my calculator? 0.85. Yeah, just the percent to the left of the value. 0.85. And then just your mean and standard deviation. So that's 65.5 and 3. So as a class, we got, oh crap, what was it? I forgot. 68.6. Makes sense to me. It's a little bit higher than the mean. Yeah, 85 percentile, and we're good there. Okay. Questions on that? Here's where I start to trick a little bit of people. They kind of get confused with this. So try to work with me here. It says what height do 60% of women measure above? All right, well, let's again start right here in the middle. What percent of people fall above the mean from this point? How many people fall? What's the percent of people that fall above? 50, right? Yeah. So if I'm talking about women being 60% above this value, is that value going to be to the right or to the left of this mean? To the left, yeah. It's 50% here. A little bit to the left here is going to give me an area of 0.6. See that? So I want to know the value that corresponds. I want to know the value that 60% of my women are going to measure above. And remember, the height was 65.5 for the mean. Okay, remember what I said. Our calculator is dumb. It only will do value or percentages to the left. So what, if I'm asking for 60% above, what is that the same thing as below? Yeah, 40%. Yeah, 1 minus 60 or 0.4. So the same value that's 60% above is the same that is 40% below. So in my calculator, for the area, yeah, don't plug in 0.6, you plug in 0.4. That's the only like tricky part is you just got to decide is it the area above or area below, and then you got to always make sure it's the area below. The mean was still 65.5. Sigma was 3. Your answer should be below 65.5. 64.7. Agree? Sure. So if you're 64.7%, or sorry, 64.7 inches, then 60% of women are taller. Questions on that? All right, only got 2 more examples, and they're the same things, but it's just different wording. I just want you to understand. It's the same process. It says that suppose the mean SAT score during a given year was 980, with the standard deviation being 190, and it's normally distributed. I want us to find the score that's the cutoff for the 80th percentile. What does it mean when I say 80th percentile? 80%. You are literally better than 80% of the people that you're going against. 80% of the people in the data. So 80% is higher than the mean. It's somewhere over here, right? I'm not going to give the exact value, but I'm looking for the value on my curve where 80% to the left of it is. That's what it means to be in the 80th or 10th percentile, is that you have that much percent below you. I know that the mean is 980, so that value better be bigger than 980. So it's the same question. You're still typing in the same stuff. Your area is still 0.8. Your mean is 980. And your standard deviation is 190. What's what? I'll say 1140. So you got to score an 1140 on the SAT to be in the 80th percentile. Makes sense to me. It's bigger than 980. I'm happy with that. Questions on that? All right, last example, and then we'll be done. Find the cutoff to be in the top 5%. OJ. 100%, yes, very good. If I say top 5%, you're in the top 5%. You're really far right. You're all the way like over here, where only 5% of people have scored higher than you. If I say top 5%, I mean you are in the 95th percentile. You have scored better than 95% of the people in the data. I mean, have you ever gone to the doctor and they were like, you're in the 80th percentile for your height, for your age group? Doctors did that for me before. I was always on top. Lots of high school. So my area is 0.95. Mean is still 980. That's a weird look. Okay. Sigma is, what was it, 190?
Yeah.
That's up to you. What'd you get? 1293? Cool. You have to score a 1293 to be in the top 5%. I like it. What's that out of? I forget what kind of 1400 or something. Any questions? Where's our thumbs up today? Feel good? Up, down, down. So I got, I don't know, get videos over. Smiley face.